Okay, this is chapter 5 and it's on the normal distribution. And on normal distributions, which are bell-shaped curves, which you'll see here in a second, about 68% of your data or of your scores lie within one standard deviation on both sides of the mean. 95% lie within two standard deviations on both sides of the mean, and 99.7% of the area lies within three standard deviations on both sides of the mean. And we can show you this here on the Excel sheet. Go to the Z and T score sheet, and at the very top, if we scroll to the right, we can put in a Z-score. A Z-score tells you how many standard deviations you are above or below the mean. So if I make my lower Z -1, meaning one standard deviation below the mean, and my upper Z-score 1, I see that I get an area of about 0.682. In other words, there is a 68.26% chance that people will score within one standard deviation on each side of the mean. The Z-score for the mean is 0 because that means that you are right at the mean. There are no standard deviations above the mean or below the mean. As you go above the mean, your Z-scores go positive, and if you go below the mean, your Z-scores go negative. So, for example, if we go two standard deviations on each side of the mean, the lower Z-score would be -2, and the upper would be 2, and we can see that we do get about 95% of the scores fall within two standard deviations of the mean. And you can see that on this graph here, that they fall within, a lot of your data falls within two standard deviations of the mean. And this is what we mean by a normal distribution here, that's bell-shaped. And actually the curve comes down and is asymptotic to the x-axis, which means it gets closer and closer to it but never hits it. So we can go three standard deviations on both sides of the mean, and we see we get 99.7% of your data falls within three standard deviations of the mean. Now you can go out farther. You know, if your Z-score, if you want to find out how much is between -5 and 5, almost 100%. See, it goes farther than what this graph shows. This graph only shows from -4 to 4 because typically you don't have Z-scores bigger than 3 unless there's something unusual going on. If you are three standard deviations above the mean, in other words, you have a Z-score of 3, then you are excellent. You are better than a lot of people. If you have a Z-score of -3, then you are worse than a lot of people. You're way down low. So let's go ahead and do some problems on this. And the first problem says the college only has room for one more student. The student is picked based on their SAT or ACT score. April took the SAT, which has a mean of, April took the SAT, which has a population mean mu of 1,000 and a standard deviation sigma of 100. Her score on the test was 1150. Bev took the ACT, which has a mean mu of 36 and a standard deviation sigma of 6, and her score was a 46. Who gets into the college, April or Bev? Well, the thing that we need to do is compare their Z-scores. See who scored the most standard deviations above the mean. Both of these people scored above average. 1150 is better than 1,000 and 46 is better than 36. But who scored the farthest above average? Well, if we take 1150 minus 1,000, we get 150. But those are different units than taking 46 minus 36. That's only 10. So what we need to do is divide by the standard deviation. So we take, for example, with this first student here, April, well, she had a score of 1150, the mean was 1,000, and the standard deviation was 100. So we take her score, 1150, subtract off the mean, 1,000, and we get 150, and then divide that by 100, and we get that she is 1.5 standard deviations above the mean. Now let's do the same thing for Bev. And with Bev, if we take her score, which is 46, subtract off the population mean, 36, and divide that by the standard deviation, 6, we get that she is 1.667 standard deviations above the mean. So who did better? Or who gets into the college? Bev would, because she's more standard deviations above the mean than what April is. Now actually that's what the Z-score tells you. A Z-score, or also called the standard score, tells you how many standard deviations you are above or below the mean. Again, if it's positive, you're above the mean, and the bigger the positive number is, the farther above the mean you are. And if it's negative, you're below the mean, and the bigger the negative number is, the farther below the mean you are. If you actually score the mean, then your Z-score would be 0. So again, a Z-score of 2 means that you're 2 standard deviations above the mean. A Z-score of -2 means that you're 2 standard deviations below the mean, and a Z-score of 0 would mean you scored the mean. Here's example 2. it says Bev has a score of 2 on a test that has a mean of 50 and a standard deviation of sigma of 5. Well, when it says standard score, that's referring to her z-score. So we know that her z-score is 2, her mu is 50, and her standard deviation is 5. So if we solve this formula, z equals x minus mu over sigma, for what we don't know, which is her score, x, then we would cross multiply and get z times sigma equals x minus mu. Then adding the mu, we get this new formula, x equals mu plus z times sigma. If we just substitute our numbers in now, we can answer this problem. So we get x equals mu, which was 50, plus z, and that's our standard score, which was given to us to be 2, times sigma, which is 5. And if we work this out here, we get 60.